Archimedes' principle is the idea that if you have water and you place an object inside it, how do you know how much of it is actually afloat above the water, how much is actually inside? And how you know, and the formula is, if you take this volume of the object, the one that is under the water, and it has this V, then that's also the volume of the water displaced with having the object inside the water. And if this whole block has a certain mass, then mg is going to equal the volume of water displaced times the density of water times g. So let's think of this conceptually. We know that when you have seesaws, you have a balancing act going on. Everything on this side has to equal the same weight as everything on this side, or else your seesaw will tip. Or this is a bad example because torque is involved, but if you think of scales where torque isn't a problem, then everything on this side is balanced with everything on this side, or else you would have rotation here. The same is the case for water, where in terms of water, every single point on the surface is like a scale. So that every single point has to have the same force on it and supporting from the bottom so that your water doesn't change shape, instead it's flat. So in order for it to be flat, then if you put an object inside the water, then the weight of that object needs to be the same as the weight of what water would have been there if the object weren't placed in the water. So even if some of the object is above the water, the total mass is concentrated into the volume it has displaced, and the weight of that displacement has to be equal to the weight of the water itself. And if you want to think of icebergs, why are icebergs so heavy? So much of the iceberg is under the water and so little is above. Well, if we just analyze this, there's so much of the volume inside, so we say that the mass is equal to the volume of the water. And since so much of the volume is inside, is being the displacement of the water itself, we can say that if we have the density of the ice, V equals the density of the water, V. Because these values are so close, just knowing the nature of icebergs let us know that Pi is fairly close to the density of water.